Hello everyone, welcome to Jiggy Maths. So I'm here once again to give you another lesson video, which is a continuation of the binomial expansion. So the topic for today is about the application and more problems involving binomial expansion. So let's begin with the application. So the application of binomial expansion has something to do with estimating the value of the numbers. So without the use of calculator, you can actually use binomial theorem to estimate a certain value. Okay, so let's have the first application problem. Find the first four terms in the expansion of 1 plus x to the power of 9 in ascending powers of x. Then use the result to estimate the value of 1.01 to the power of 9. So there are two questions involved in here. So let's start answering the first one, and that is to find the first four terms in the given expansion. By the way, by now, you should have known already how to expand a certain binomial. Now, just in case you forgot, you can go back to my past videos and then try to relearn, okay, on how to do the binomial expansion. Okay, so 1 plus x to the power of 9, and we can already do this horizontally, and that will be equal to combination of 9 taken 0, 1 to the power of 9, x to the power of 0. So as we can recall, the coefficients will be combination of 9 taken 0, and then the next will be combination of 9 taken 1, combination of 9 taken 2, then combination of 9 taken 3. As for the powers of the first term, they are decreasing, okay, starting from the given index, which is 9. So the next will be 1 to the power of 8, 1 to the power of 7, and 1 to the power of 6. And then for the second term, the powers will be increasing starting from 0. So that will be x to the power of 0, x to the power of 1, x squared, and x cubed. So the other four terms will look like this. Okay? And of course, we know that 1 to the power of any number is equal to 1. So we will have this. Combination of 9 taken 1 is 9 times x is 9x. Combination of 9 taken 2 is 36x squared. And combination of 9 taken 3 is 84x cubed. So these are the first four terms. And as you notice, the powers of x are ascending from x to the power of 0, 1, 2, 3. So they are increasing, correct? Okay, now very important here is the next one. Use the result, okay? Use the result. So this phrase is very important, and make sure that you follow this because you can in fact use your calculator to get the value of 1.01 to the power of 9. But what's more important here is to use the result and show you're working, okay, to get the estimated value. All right, so how can we use now the first four terms to estimate to get the estimated value? So as you can see, what we want is 1.01 to the power of 9, and we use the 1 plus x to the power of 9. So 1 plus x, 1.01, so it follows that what? 1.01 can be written as 1 plus zero point 0.01. So it follows that x is equal to 0.01. But we know that the first four terms of this expansion is this. So what we can do is what? It's just to plug in the value of x, which is 0.01, in the first four terms of the expansion. So it will be now 1 plus 9 times 0.01 plus 36 times 0.01 square plus 84 times 0.01 cube. Okay, now it is important for you to show this working. That is the evidence that you have understood and that you have followed the instruction. So of course, when you are taking a test or an examination, you always have your scientific calculator. So what's good thing about this question is you can use your calculator to verify, to check if your answer is correct. Okay, so meaning we can use our calculator to evaluate this. All right, so and this is what we're going to get. and that will be 1.093684. So any answer that is somewhat not similar to this will be definitely marked wrong. Okay, so this is more of following the instruction and using the previous answer from the first question to answer the second question. Now let's look at the second problem. Obtain the first four terms in the expansion of 2 minus x over 2 times 1 plus x to the power of 7. Hence, estimate the value of 1.95 times 1.1 to the power of 7. Okay, so again, this is an application of binomial expansion. So let's obtain the first four terms, and this is what we're going to have. Okay, so 2 minus x over 2, so you do the usual way of expanding the binomial. 1 plus combination of 7 taken 1 times x, because 1 raised to any number is equal to 1. So I didn't write it anymore, okay? So next is combination of 7 taken 2, x squared plus combination of 7 taken 3, x cubed. Alright, so of course we are going to distribute this two terms, 2 minus x over 2, to this expansion. Okay. All right. So this is what we're going to have. All right. So 2 multiplied to 1 is 2. 2 multiplied to 7x is 14x. And do for the rest, and we will get 42x squared plus 70x cubed. And then negative x over 2 will also be multiplied in this expansion. By the way, we didn't actually complete the expansion because this is raised to the power of 7. So we are expecting 8 terms, right? But I didn't um, fully expand it, but because what we need only is first 4 terms. Okay, so you're going to see why we actually stop at this 4 terms in the expansion of 1 plus x to the power of 7. Okay, so let's distribute now. Negative x over 2 times 1 is negative x over 2. Then negative x over 2 times 7x is negative 7 over 2x squared. The negative x over 2 times 21x squared is negative 21 over 2x cubed. Now, negative x over 2 times 35x cubed, I didn't anymore continue that because again, what we need is only first 4 terms. So, um, adding them all up, we will get 2 here. 14x added to next negative x over 2, you will get 13.5x because negative 1 over 2 is negative 0.5, right? Then 42x squared minus 7 over 2x squared is 38.5x squared, and you will get for the fourth term, which is 59.5x cubed. So once again, this is very important for you to present in your working. Okay, now hence, so this word, it means, if you see this word, this command term expects you to use the result from the first question uh, to answer the second question, and that is to estimate the value of 1.95 times 1.1 to the power of 7. Okay, so um, from here, the next thing to do is to find the value of x. Okay, so you see the this one is very similar to this. So 1.1, 1 plus x, so it follows that x should be 0.1. All right, now you can also verify if your x here is 0.1, you will get 2 minus 1 half, and that's going to be 1.95. So x therefore is 0.1. So if x is 0.1, then we need to use the first 4 terms to get the estimated value. So all we need to do is just plug in 0.1 to x in this expansion, and this is what we're going to get. So 2 plus 13.5 times 0.1 plus 38.5 times 0.1 square plus 59.5 times 0.1 cube. All right. And by the way, this notation is the approximation notation. We can use that. And the answer is 3.7945. So once again, any answer that is different from this will be definitely marked wrong. Okay? Now, if we're going to use your calculator to get the value of this, you will get a different answer. Of course, that is the more precise value of this, but what we want is the estimated value. Okay? So there must be an evidence um, of using the answer from the first question to get the estimated value. All right, now moving on. More problems involving binomial expansion. So I'm going to discuss three things here. One is that involves a ratio. The other one has something to do with relationship between coefficients. And then the other one is expanding a trinomial. Not just expanding binomial, but expanding trinomial. But we are going to use binomial expansion to expand a particular trinomial. Okay, so let's have the first problem, that is with ratio. In the expansion of 3 plus kx to the power of 20, the coefficients of x to the power of 4 and x to the fifth power are in the ratio of 3 is to 16. Find the value of k. So here, these are the given, okay? So notice that I always underline the given information. Okay, so coefficient of x to the power of 4 and x to the fifth are in the ratio of 3 is to 16. Okay, so that means we need to find the x to the power of 4 term. Okay, and that is from this expansion, for us to get the x to the power of 4, r must be equal to 4. Okay, so the x to the power of 4 term will be combination of 20 taken 4, 3 to the power of 16 because 20 minus 4 is 16, and then kx bracket to the power of 4. While x to the fifth term will be, for us to get an x to the fifth term, the kx must be raised to the power of 5. Okay? And then it follows here that 3 should be raised to 20 minus 5, and that's 15. So r is 20 combination taken 5. Okay, so we have the x to the power of 4 term and then x to the fifth term. But what we want in the given information, the coefficients are in the ratio of 3 to 16. So let's just get the coefficient. From the numerator, we will have um, combination of 20 taken 4, which is 4,845, and then 3 to the power of 16, and then k to the power of 4. So we don't want any more the x to the power of 4 because what we just want is the coefficient. And likewise, for the coefficient of x to the fifth power, combination of 20 taken 5 is 15,504 times 3 to the power of 15, then k to the power of 5. All right, without the x to the power of 5. And it says that this is equal to 3 over 16. The ratio is 3 is to 16. So all we need to do is just to simplify this. Okay, so cancel out k4, k5, and then what remains in the denominator is k. Now 3 to the power of 16, 3 to the power of 15, we can also cancel it out, and then what remains is 3 up there. Okay, so simplify that, we will get 5 times, okay, so simplify this, we will get 5 over 16. And then 3k is equal to 3 over 16. So we can still cancel out 3 and then 16 below. And then what remains is 5 over k is equal to 1, and that will give us k is equal to 5. Right? So find the value of k. We already found the value of k, and that is equal to 5. Okay? All right. What about the second problem that involves relationship between coefficients? So the coefficient of x squared in the expansion of 2x plus k to the power of 6 is equal to the coefficient of x to the power of 5 in the expansion of 2 plus kx to the power of 8. Find the value of k. So what we meant by relationship is this. Coefficient of x squared is equal to the coefficient of x to the power of 5. Sometimes it is coefficient of this is twice the coefficient of this. Okay, so and then from there we can come up with our equation. So coefficient of x squared, which is the x squared term, let's look for the x squared term and x to the fifth power term, and we will have the following. So coefficient of x squared is for this particular binomial, 2x plus k to the power of 6, right? So for us to get an x squared, the 2x, which is the first term, must be raised to the power of 2, okay? So since the index is 8, so it follows that the power for the second term is 8 minus 2, which is 6. Okay, so it gives us now our value, which is 6. So we will have combination of 8 taken 6 here. For the x to the fifth term, okay, so we're talking about the x to the fifth term in this binomial expansion. So the kx, or the x, is in the second term. So for us to have a fifth power, the kx must be raised to the fifth power. And it follows that the power, or the index, for the first term is 8 minus 5, which is 3. But what we want only are the coefficients. So we will get now the coefficient of x squared is equal to coefficient of x to the power of 5. And this is what we're going to get. All right? So notice that when 2 is distributed to 2x, we will only get 2 squared. Of course, we need to remove x squared because we're just after the coefficient. And then for the other one, uh, the index 5 being distributed to both factors, k to the power of 5, and then remove definitely the x to the power of 5. Okay, so this is now our working equation, and what we want is to find the value of k. So just simply evaluate this, and then of course cancel out the common factors, and we will get k is equal to 4. Alright, now moving on to the last problem, and that is expanding a trinomial. Find in ascending powers of x the first three terms of 1 minus x minus 12x squared to the power of 4. Okay, please do not be so worried about this. How are we going to expand this, this trinomial, polynomial consisting of three terms? The three terms are 1, negative x, and negative 12x squared. And then expand that, meaning, are we going to multiply this 4 times? Okay, of course, if you want, that's a valid method. You can do that definitely. But of course, it is very time consuming. And what we want only are the first three terms. Okay, so what we can do here is, if you notice 1 minus x minus 12x squared, it is actually factorable. We can factorize it. So 1 minus x minus 12x squared will be 1 plus 3x multiplied to 1 minus 4x, and then raised to the power of 4. So this trinomial was, we were able to express this trinomial as a product of two binomials. And from the law of index, the 4 can be distributed to each factor, and this is what we're going to get. All right. Now I made this red just to distinguish that from the other factor. So of course by now we should know how to expand this, and this is what we're going to get. Now again, first three terms. So if this is index 4, we should have 5 terms, but we don't need, because what we want is only the first three terms. Okay, so for the other one is, we have 1, 2, 3. Okay, just be careful with the negative here. All right, so okay, so simplify, we will have 1 plus 12x plus 54x squared, and then we will have 1 minus 16x plus 96x squared for the other factor. Now, it is okay for us to exceed here, okay, the number of terms, because when we distribute now all of these three terms to the other one, that's where you can now somehow limit, okay, considering that we want only the first three terms. Okay, so 1 multiplied to this factor, we will get also definitely the factor itself, so 1 minus 16x plus 96x squared. Then 12x multiplied to the other factor, we will get 12x. 12x times negative 16x is negative 192x squared. and then it follows that for the other one is 12x times 96x squared is this one. So imagine if we're going to add this, vertically, we can already get the first three terms from starting from here, and then we can stop here. Okay, so that means we don't need any more than 115 2x cubed, right? So that means we can now get the first three terms, and we will have 1, and then negative 16x plus 12x will give us negative 4x, and we add all of these to get the three terms, and that is negative 42x squared. So we have already answered the question, and that is to find the first three terms in ascending powers of x. Okay, so hope that you learned something from me today again. So thank you to Slides Carnival for my PowerPoint template. And once again, thank you very much, and hope to see you again very, very soon.